Okay, so I'm just waiting for that screen to come on. This is all in pink. I'm just going to actually go over it in blue, if you can see it better. And let me zoom in as well. Okay, guys, so they asked you to find the angles labeled A to M in terms of X. So that means that your answer must have an X in it. So the first few were quite straightforward. In number one, they gave you the angle at the center was 2x. So the one at the circumference has to be half of that. So just x. For number two, the angle at the circumference is 2x. So the one at the center will be double that. So 4x. You can just look at those. I will explain how we got to the answer in number 6 just now. I'm just quickly going over all of these in blue. All right, just quickly mark 1 to 5, and then I'll explain number 6, especially that 90 minus x, where that answer, or how you would have been able to find that answer there. Now, guys, in number 6, what I want you to recognize immediately, and we spoke about this quite a bit in yesterday's lesson, so if you haven't watched that video, you need to, please. It wasn't very long because it was just half an hour, the lesson. So this triangle here, the bottom one, is an isosceles triangle, right? Because that line and that line, they are both radii. And we should know that radii, wherever they are in a circle, they will be equal, right? So this is, in fact, an isosceles triangle. And if you just look across at yesterday's marking, I put it in on all the triangles where you had to use that. So this is the other part. So you must just mark from the video there if you haven't. But in all of these questions, we actually had to use the fact that the triangles were isosceles triangles. All right, so that is quite important that you understand that. So I'm just going to say again, these are radii, so they are equal. So if you have that angle is 2x, right? Then the other two angles, if you add them to 2x, must give you 180, right? Because we know that 3 angles in a triangle must add up to 180. And then if you have the sum of the 2 angles, because they're equal, you can just divide that by 2 to get what each of them will be equal to. So the working that you would have to do here, you would have to say 180 minus that angle that we have, the one that we have, which is 2x. All right, that will give you the sum of the 2 angles at the bottom. So the sum of this angle G, and that would also be G, right? So those 2 angles together would be 180 minus 2x. I hope that makes sense, right? But then to get one of them, you could divide them by 2. You could divide that, the whole of the 2 angles by 2, because they're equal. All right, and then what is 180 divided by 2? 90 minus what's 2x divided by 2? X. All right, so that is how I got to that answer, 90 minus x. First, you take 180, you minus the one angle that you have, which is how we got 180 minus 2x. Then you divide that by 2 because the 2 angles are equal. Now, if you were to write this in a test or exam, you obviously have to do all the reasons as well. So for the 180 minus 2x, that would be angle sum and triangle. All right, so that would be your first reason. And you must have done these last year, all right? They must have come up, I'm sure. So angle sum and triangle. Then the fact that these 2 angles are equal, we know that because it's an isosceles triangle. The reason for that is angles opposite equal sides. And then how do we know that this is an isosceles triangle? Why are those two sides equal? Because they are radii. Okay, so you have to write all three of those reasons in order to get all the marks. Okay, I know for this exercise you didn't have to do reasons, but just those would be your three reasons for that working. Does that make sense, guys? All right. So it came up a couple of times again. In the next one, I think it came up again, where we had that the angle at the circumference was x, meaning that the angle at center has to be 2x because it's always double. And then we actually have exactly the same. Oh, sorry, I didn't fill this one in here. Oh, it was given as x. Oh, never mind. So it was actually literally the exact same question. The triangles just looked a bit different, right? Sorry, so in number 6, I forgot to mention that this top angle is 2x because the angle at the circumference was x. Yes, Talia? Radii. So the same thing happens here, right? Exactly the same as in number 6. So the angle at the circumference is x, meaning the angle at center will be 2x. Then to get those two angles, you would say 180 minus 2x. Because they're equal, you would divide that by 2. Okay, exactly the same as number 6. For number 8, this is the more difficult angle at center one. All right, it's not as easy to spot this. So if this is your angle at the circumference, guys, that angle x is actually subtended by this major arc, that whole arc, right? The one at the bottom. Does that make sense? Because the lines coming from the end points of the major arc meet and form angle x at the circumference, right? Now, which angle at the center is also subtended by this major arc? Actually, this whole one at the bottom there, the reflex angle, right? So that's a difficult one to see. Angle at center and angle at circumference, they have to kind of be on the same side, if that makes sense. So this one can't be the angle at center and that one the angle at circumference. They have to kind of both be facing down. I don't know if that makes sense. All right, so that would be 2x. And if we were to write that down, we would say reflex O is 2x. Then we know that these two angles together should add up to 360 degrees because they are around a point. So if that one is 2x, then J will be 360 minus 2x. All right, then similar thing over here. We have that angle is x, meaning that angle will also have to be x because it's an isosceles triangle, right? If we know that is x and that is x, that's going to be 180 minus 2x, the angle at the center, and the angle at the circumference then has to be half of 180 minus 2x, which is just 90 minus x. Any questions on this one? All right, worksheet 4, the next one. All right, you can take a look there. So for all of these, the reason would have been angles in same segment, right? Because these angles are subtended by the same arcs. In this case, they didn't actually draw in the chords for 1 to 4. All right, so it was just arcs. But these two angles are subtended by the same arc. They're both at the circumference, so they're equal. Same thing here, same thing in 3, same thing in 4. Now in number 3, we have this bottom arc here subtending those two 40-degree angles. But then if we're looking at this top arc, that one subtends these two angles almost at the bottom of the circle, right? So those two 20-degree angles would be equal. You can just look at the next ones. In number 6, you had to think of alternate angles as well. So I think I found I first. If that is 40, then that is also going to be 40 because of angles in same segment, right? Then I used my Z shape over there because these lines are parallel. So if that's 40, then that must also be 40. And then we can look at angles in same segment from the top there. Those two angles are formed by the same arc. So that one is also 14. And then I just used angle sum and triangle to get that 100-degree angle. Let me know if you have any questions on these ones. We still do have to look at 9 to 12 on the next page. The other half of the page, rather. All fine? All right, I haven't finished actually. So number 9 is over there. And then I'll just do 10 to 12 with you. So what you had to do for number 9, they're telling you that this is an isosceles triangle, right? We couldn't see that because these lines actually aren't radii, all right? So they have to tell us that these two lines are equal, meaning that those two angles will be equal. So the calculation, you're going to say 180 minus 94. That will give you the two angles together. Because they're equal, you then divide that by 2, and you will then get 43. So actually both of these angles are 43 degrees. All right, but this is the one that they actually asked us to calculate, that one. So now, do we notice that it's subtended by the same chord, right? So if that is 43, that is also 43. Any questions on that one? Yes, so first you would do those 3 reasons, well, actually 2, for getting this 43, and then you would say angles in same segment. All right, number 10, what's happening here? What is this line? It's not really very clear, but I'm hoping that you guys spotted that there's a point over there. Now, I mean, I suppose you had to assume that that was the center. Normally, we would actually tell you that it's the center. Okay, so this wasn't really that clear. But that makes this chord actually a diameter. Okay, and we know that a diameter subtends what angle at the circumference always? A right angle. Okay, so this diameter is actually subtending 2 angles at the circumference. Both of them will be 90. All right, so S is 90 degrees and T is also 90 degrees. The reason for that would be angle in semicircle. Yes.
So if you said S, angle in semicircle, but then for T, angle in same segment, would it be?
You could have done that, yeah. That's fine. Now we need to find U. Now again, they've told us that this is an isosceles triangle, right? Those two sides are equal. So if that's 90, what must these two angles be equal to? 45 each, hey? So 45 degrees there. You could also do that calculation. You could say 180 minus 90 and then divide that by 2 if you didn't do that in your head. All right, but you would get to 45 degrees anyway. Okay, nearly there. 11. We just have to find one angle here. Do we notice that this chord is subtending a 32-degree angle? And then a completely different chord is subtending angle V, but they are equal in length. Right? So if they are subtended by equal chords, the angles will also be equal. So V is 32 degrees. The reason there is equal chords, equal angles. Okay, last one. Sorry, guys. 120 degrees here. We need to find that angle, right? What are we going to need in order to find W? Do we see that W is subtended by this chord? Right? But this chord also subtends that angle over there. Right? So if we can find this angle, then W will be equal to that angle. Now, how can we find this one at the bottom here? Thank you. It's an isosceles triangle, right? So we're going to say 180 minus 120 is 60, meaning that those two angles together must equal 60, but they're equal to each other. So 60 divided by 2 is 30. So that angle and this one, both of them are 30 degrees. And then we can just use angles in same segment to say that W is also 30 degrees. Yes. I will just now. 9 is up there. Any questions here, guys? Are you all fine? No problem. Okay, I printed those notes for you, the notes that we looked at the other day, so just planning it out. For the sake of the planet, I have to do 10 double-sided. So I know it's a bit of a pain to you guys, but I need to do my list right now. Oh, yeah. I'll cry about it. I know, sorry. Also hate killing the sun, but also like 45 degrees today. Hey guys, did everyone get one page now? So that page has the terminology on the one side, on the other side, it has the circle theorem summary and two of the proofs that you need to know. If you want to stick it in, I will stick it in that book. You don't really need it. Right, so stick it in like that, and then you have all the theorems. Okay? So now we're going to practice doing all of those theorems together. These exercises have been very like, you know, the separate theorems at the time. What? She did that. You copied it down. That's nothing. Sure, I also would have. Okay. All right, repeat it, guys, stick that in quickly, please. We need to keep going. All right, I'm taking that in, please write that down. Yes. Say again? I don't know. Yeah, I think probably still next week. Oh, hopefully as soon as possible. If we can go back. Okay, are we ready? Let's get going. Oh, Vicky, please. Groups. Possibly. I think you must just have to miss learn about that. That was so quick. You didn't even have to think of that.
In group 1, who does more days?
That's true.
Next week we have 3 days, and this week we have 3 days.
Group 1 just one to gonna go to group 2, and then you're gonna get over there.
Oh, maybe it's me instead.
Must be okay. Yes, write it down, please.
I've done it.
Guys, a rider is like a question that has all the, I don't really know why they're called riders. I don't know where that word comes from. It's just in all the headings. So with geometry, riders are just like mixed examples. All right? I don't know. It's in the heading of the thing. All right, so we're going to do 1 and 2 together, and then hopefully we can move on to cyclic quads, which is something new. All right, so that is what I'm aiming for. So 35 minutes, so we're pushing. All right. So please write that heading. You can just write circle geometry riders. You can see that the heading says grade 10 because these questions only involve theorems that you learned in grade 10. Okay. They actually did give you this worksheet last year as well, but I think it's good to just go through it again quickly. Okay, so number 1. Guys, this worksheet is obviously on Google Classroom. Okay, I'm not going to print it out as well. We're going to write it down properly with the reasons. Okay, if you want to later on draw in the whole picture next to your working, then you're going to have to do that on your own time, unfortunately. Okay, but you're more than welcome to do that. Okay, so number 1, they're saying reasons with correct wording. Obviously, they always have to have the correct wording, are required for all questions. In the figure, M is the center of the circle. Now, what does that mean for GE or EG? It's the diameter. All right, so let's keep that in mind. There we have an angle at center. There we possibly have an angle at center. We have an angle at the circumference there. Okay, it's quite a good idea also before you actually try to answer the questions to just familiarize yourself with what is actually going on the picture. Okay. They're saying D, E, F, and G are points on the circumference. Now, guys, I haven't put any values in here. All right, these little 1s and 2s are just naming the angles in a better way for us, meaning that we can refer to angle F1 instead of saying MFD. All right, so these little 1s and 2s, do we notice that they don't have degree symbols next to them? That means that they're not the sizes of the angles. Okay, so please don't think that this angle is 1 degree and that angle is 2 degrees. Okay, they only are giving us the sizes of the angles if they literally have put the degree symbol there as well. Okay, now they're saying if F1 is 7 degrees, so that's not filled in there, so you would have to fill that in. All right, obviously you don't have this in front of you, but in a test or exam, whatever, it's good to fill those things in. And they're saying that D2 is 51. Now D is there, so D2 is 51 degrees. Calculate the sizes of, now we're going to find these angles. And guys, every time you calculate an angle, you put the size on the picture. All right, they usually follow on from each other. So if we are finding D1 in A, we might have to use D1 to solve B. All right, so whatever you find, we need to put that in. Okay, D1, this angle over here. Any ideas? Yes. Angle in semicircle, right? Yes. All right, so here we have the diameter. We know that a diameter subtends a 90-degree angle. So angle D, the whole thing is 90. All right. You can draw that in if you want. Now, if we know that that part is 51, then D1 is going to be 90 minus 51. Okay, let's write that down. 1A, angle D1, 90 minus 51. And the reason there is angle in semicircle. Oh, sorry, that's quite big. All right, so what is that? 90 minus 50 is 40, and then minus another one is 39. Hey, so angle D1 is 39 degrees. You also could have just written D1 equals 39 straight away with your reason. That also would have been fine. Okay, so D1 is 39. We'll find that one. All right, for B, now we need to find M1. Now, guys, you see what I meant? M1 is now the angle at the center, subtended by EF, And D1 is also subtended by EF at the circumference. So now we actually need to use this answer to get M1. All right. M1 is going to be double D1 because D1 is at the circumference and M1 is at the center. What's 39 times 2? 78. All right. So M1 is equal to 78 degrees. Angle at center equals 2 times angle at circumference. Okay, next one. So now I've put my 78 in there. Now we need to find F2. Now guys, we're going to use that isosceles triangle thing. Okay, do we notice that? If we're looking at this triangle here, EM is equal to FM because they're both radii. So that's going to go in our reason. We have 78. So we're going to say 180 minus 78. That will give us those two angles together. But then to find F2, we're going to have to halve that value. All right, so if you want to do the actual working, you can write it down like this. You can say F2 is equal to 180 minus 78 over 2, like that. Okay, you don't have to do it all in your head. You're welcome to if you want to, or just on the calculator, but that's how you would write the working down. Then you say angle sum in triangle, because that's the 180 minus part. And then the reason why we can divide by 2 is because of angles opposite equal sides, because it's an isosceles triangle. But how did I know that it's an isosceles triangle? Because those two sides are radii. Okay, so you have to put all 3 reasons in. They normally award 2 marks for having all 3 reasons. So if you leave out 1, you lose 1 of those marks. If you leave out 2 of them, you lose both marks. Okay, so it's important that you have all 3. What is 180 minus 78? 102. Hey, what's 102 divided by 2? There we go. So F2 is 51 degrees. Okay, I put it in on my picture. Now guys, we can also actually just put in that E2 is also 51, all right, because these two angles are equal. We already said that they're going to be equal by dividing by 2, all right, so we might have to use that. The next one is now asking me to find angle G, which is up here. Now, what do we think for that one? Let's look, what is angle G subtended by? Which chord forms angle G? DE, hey, do we notice that? Does DE subtend another angle at the circumference anyway? So we look for lines going from the end points of DE and they meet at angle F, right? Do we notice that? So angle G is going to have to be equal to angle F because of angles in same segment. Right, check, does that make sense? They're both subtended by chord DE. Now what is F altogether, guys? 7 and 51 is 58. So angle G is also going to be 58 degrees. So that is D, angle G is 58 degrees, angles in same segment. No, you don't have to. You can literally just say angles in same segment. If you want to for yourself, if you want to say chord DE, you can, but they don't give marks for that. Well, you have to use that wording, but you can add the chord part if you want. Okay, but those words have to be there. All right, that's number 1. Are we happy? Okay, number 2 is a bit more complicated. All right, so in number 2, we have 2 circles. They're saying in the diagram, O is the center of the smaller circle. All right, so that point there is the center. Chord BO of the larger circle. So here's our larger circle, and BO is a chord of that circle. Right, so what can we actually see? We see that the center of the small circle is on the circumference of the bigger circle. Right, do we see that? Because O is the center of the smaller circle, but it's actually also a point on the circumference of the bigger circle. All right, so now they're saying BO is produced. Now produced, that basically just means that it's been lengthened, all right? It's been extended basically. And cuts chord AD of the smaller circle at M. So we're saying that BO and then BOM, that's actually all one straight line. Okay, that's what they're telling us. And if we're looking at it this way, OM, and we're just looking at the smaller circle now, do we notice that OM is from the center of the circle and it's going to a chord, right? We haven't really practiced those first 2 theorems, but remember there were theorems about a line from the center of a circle to a chord. Okay, those theorems said that if the line is perpendicular to the chord, it cuts the chord in half. But the other way around said that if the line goes to the midpoint of the chord, then it is perpendicular to the chord. I'm talking about on the summary page, those first 2, that's what I'm referring to. Okay, so we might have to use that. Yes?
They haven't told you to cut it up to midpoint.
Yeah. Well, they might still. I haven't. Yeah, they haven't told us that. But maybe we find the 90-degree angle or something somewhere. So it's just something to keep in mind. Okay, so they're just saying that it cuts chord AD of the smaller circle at M. And then they're telling us that B2 is X. All right, they didn't fill that in, but B2 is X over there. Now, 2A is asking us to find 3 other angles each equal to X. And this is a common test question where they give you one angle that's X and then they say, find 3, 4, 5 other angles that are also equal to X. So let's first look at which chord is subtending this angle B2. Do we agree that B2 is an angle on the circumference, at the circumference of the bigger circle? Can we all agree on that? B2 is an angle at the circumference of the big circle. So let's just cover up the small circle for now, okay? It's a bit confusing. Which chord is subtending B2? Let's look at the lines that form that angle, and they're going back to CO. Right? Do we agree with that? CO subtends B2. Can we see that? Right? CO is over there. Does CO subtend any other angles at the circumference of the big circle? A2. Look at that. Do we all agree with that? CO also subtends angle A2. So A2 is also going to be X. Let's write that down. Right, so A2 is equal to X, angles in same segment. Okay, let's go back to the picture. Now we need to find another angle that's equal to X. Now we can either work from B2 or we can also work from this one, right? We can also now use A2 as a way of finding another angle. Any ideas? Maybe in the smaller circle now. First, let's just make sure, does CO subtend any other angles at the circumference of the big circle? Just double check that, because if it does, then those angles would also be equal to X. It looks to me like those are the only 2, hey? All right, so we can't use angles in same segment in the big circle at the moment. Let's look at the small circle. What do we notice there? I'm looking for another angle that's equal to x. What do we see? Isn't there, yes, Talia?
That angle AOC is equal to 2F, which would make angle B equal F. Because angle that's close is equal to my angle.
Okay, just check that AOC isn't subtended by the same chord as this one.
It is. Well, it's a radial.
Yes, so that's the right thing that you must say. Yes, Hailey? AO, yes, is equal to OC, correct? So Talia, you also on the right track? Both of you on the right track, yes? So C2 is going to be X, yes. This is an isosceles triangle, right? In the small circle. Do we see that? Because remember they said that O is the center of the small circle. So AO is a radius and CO is also a radius. So if that angle is X, then that angle must also be equal to X. All right. So C2 is equal to X. Angles opposite equal sides and radii. Now I'm not saying angle sum in triangle because I haven't subtracted anything from 180. All right, do you guys understand the difference? If I had said 180 minus angle and then divided it by 2, then I would have to add the angle sum in triangle reason, like we did here. Now I'm just told that one angle is X, so the other angle must also be X because of angles opposite equal sides and radii. Okay, now let's take a look. Yes.
Give more reasons when you're unsure, or like when you get marked down?
Yeah, if you do write the reason down, that's completely not supposed to be there then. But if you're just like expanding on a reason, so say you can't remember the exact wording of a reason, and you just say, for example, angles opposite equal sides, and yeah, I don't know, you can write more words if that makes sense. But if you write less words, then you'll lose marks. Nicholas?
No, on the question.
Yes, correct wording. Yeah.
Don't have the, is it exact or is it just more about?
It's supposed to be exact. Yes. Yeah. Okay. Can we find another angle? So Talia, you said that AOC is 2x, but if we look at this, it's actually going to be 180 minus 2x. You see, because that is x and that's x. So if you're working in this triangle, then that angle will actually be 180 minus 2x. Okay. All right, what else can we see here, guys? Talia, yes?
I think B1
B1 is equal to B2. Why?
because I said equal chord equal angle.
Yes, correct. I didn't even notice that. Well done. All right. I'm going to say that quickly. Thank you, Talia. This chord CO is subtending B2. This chord AO is subtending B1. Do we notice that they are equal in length? Right? We put that in because they're both radii. But if we're looking at them now in the bigger circle, both of them are chords of the bigger circle. And because they're equal, any angles that they subtend will also be equal. All right? Equal chords, subtend, equal angles. Well done. So B1 is also equal to X. So B1 equals X, equal chords, equal angles. That's the reason for that one. Oh, and now we're done. They just wanted 3. All right, and we found 3. Now, 2b. Now they're saying express angle AOC, which is this angle here, and we have actually already mentioned it. All right, but they're saying express angle AOC and then angle D, which is this one, in terms of x. Now remember, if they're saying in terms of x, that means that your answer is going to have an x in it. All right. Some people think if they say in terms of x, oh, I must solve for x. That's not what they say. All right. In terms of x means that your answer has to be in terms of x. There must be an x in it. Now, guys, if we look at AOC, and we have already mentioned this before, those two angles, this is a triangle, right? Those two angles are both equal to x. So to get the third angle in that triangle, we're going to say 180 minus x minus x. So what does that simplify to? Minus 2x, yes, 180 degrees minus 2x. And the reason there is angle sum in triangle. Okay, now they want angle D as well. I'm just going to turn the page like this. I don't know if that will help. Okay, we're just looking at the small circle. AOC is subtended by AC. Now they want us to write D in terms of X as well. Can we see that D is subtended by the same chord? Also by AC, right? AOC is subtended by AC and D is also subtended by AC. AOC is at the center. D is at the circumference. So D is supposed to be half of 180 minus 2x. All right, so I'm going to write it like this. Angle D is 180 minus 2x divided by 2. The reason is angle at center equals 2 times angle at circumference. And now we must just simplify that. We've done this before today, actually. 180 divided by 2 is 90 minus 2x divided by 2 is just x. So D is 90 minus x. Okay, any questions on these two, guys? We've practiced working with just numbers and now we've practiced working with x's. Okay, now we are going to see how much time we have left. 15 minutes. That's enough time to do what I want to do. Okay, we're moving on to new grade 11 stuff. It's not too bad. This is now from document 7 on the Google Classroom page. Okay, I want us to write some stuff down. It is written in the note, but I think it's good if we also actually just write it down ourselves. So, I just want to zoom out here a bit. Okay, we are going to write some stuff down about cyclic quadrilaterals. So we'll make that our new heading. Okay, a cyclic quadrilateral is a quad with all 4, because we know a quadrilateral is a shape that has 4 sides and therefore 4 vertices, right? What is a vertex? The point, right? If we're thinking of a triangle has 3 like points where the sides are meeting. We call those vertices. So a quad with all 4 vertices on the circumference of a circle. Now, the bit that I'm going to put in brackets might confuse you. We will talk about it in great detail, so don't stress now. I'm just going to add here whether the circle is drawn or not. Not draw specifically, but you might have to imagine it there. Yeah, you can try and draw it in sometimes. Sometimes I'm just going to show you in the note quickly. We're not going to, I suppose we can draw this in quickly because it's not too bad. We drew circles with Venn diagrams. So here we have an example where you can tell that this quadrilateral is a cyclic quad just by looking at it. All right, because right now we can see that A, B, C, and D, all 4 of the vertices lie on the circumference of the circle. So we can say straight away that's a cyclic quad. All right, sometimes they're going to give you a quad in a question where all 4 vertices don't actually lie on the circumference of a circle, right? Like this kind of thing. Then we need to know some other properties of a cyclic quad, which we will write down now, to prove that it is actually a cyclic quad. Once you've proven that, you need to be able to imagine that you can actually draw a circle through those 4 points. And then use that kind of imagination. You can try and draw it in if you want, but it is quite difficult. It's also not always drawn to scale. So you might not always actually be able to draw in a proper circle from there. All right, but we will get to that. But that is what I'm saying, whether the circle is drawn or not. Okay, it might still be a cyclic quad, even if there isn't a circle there. Okay, so now properties of a cyclic quad. Let's write this down. This is very important. The first thing that we need to know is that the 4 vertices are called concyclic. That's just a terminology thing. Right, so the quad is cyclic, but the vertices, we say that they are concyclic. Okay, that's just so that you can understand the question. Sometimes they say, prove that this quadrilateral is a cyclic quad. Or they can also say, prove that these 4 points are concyclic. Okay, then you need to understand that it basically is the same thing. All right. Now, number 2 is actually a theorem that we are going to prove. And this is saying that the opposite sides, sorry, not sides, angles, the opposite angles of a cyclic quad are supplementary. Now, supplementary, in case you've forgotten what that means that they equal 180 degrees. Okay, so that is the theorem. That's a theorem. If you have a cyclic quad, then the opposite angles will be supplementary. Do we remember from, I think, grade 8, maybe, grade 9, that all 4 angles of any quadrilateral, whether it's a square, rectangle, trapezium, whatever, all 4 angles have to add up to 360. Right? Do we remember that? Okay, so this is just saying that if it's a cyclic quad, then these 2 angles will equal 180 if you add them, and these 2 angles will equal 180 if you add them. That basically means that if you have that, then you can draw a perfect circle through those 4 points. Okay, I hope that makes sense. In blue, I'm going to write here the converse of this theorem is what we can use. Remember, converse means the other way around, essentially, is what we can use to prove that a quadrilateral is cyclic. So to prove that you could draw a circle through the 4 points, if opposite angles of a quad, I'll just say quad now, but obviously quadrilateral would be the correct word, of a quad are supplementary, then it is a cyclic quad. Even if, like I said in brackets at the top, even if it's not drawn with the 4 points on a circle. Okay, if that is true, then it is a cyclic quad. Okay, now I actually want us just quickly to look at one example of this before we move on to the other property. All right, so this is just a work example here. Sorry, this isn't very clear. Let me zoom in a bit. Maybe that will be better. Okay, they're saying in the diagram alongside A, B, C, and D lie on the circle, and BC is produced, all right, so extended to E. So that is telling us that BCE is a straight line. Okay, so we could use angles on a straight line over there if we wanted to. Angle B is 85 and DCE over there is 100 degrees. Determine with reasons X, Y, and Z. Okay, so they want us to find these values. So now if we're looking to find angle X, we know because these 4 points are on the circumference of a circle, this is a cyclic quad. Now we need to know that opposite angles will add up to 180. So if that one is 85, to get X, we're going to say 180 minus 85. Right, does that make sense? Your reason is then opposite angles of cyclic quad, very simple, and then you get 95. So if X is 95 degrees, do we see that the opposite angles are adding up to 180? They're supplementary. Okay, that's how it always works. So if they've given you one angle, you need to find the opposite one. You're going to minus the one that you have from 180 always. Okay. Now they want Y. That's the next one. If we have 100 there, then we can say that that will be 80. Angles on a straight line, right? That's still a thing, even though we're working in circles now. So angles on a straight line. So Y will be 80 degrees. Now, if Y is 80, what is the angle opposite to Y going to be equal to? If they have to add up to 180, what must I add to 80 to get 180? 100. Now, guys, what I want you to notice now is that this angle A is actually equal to that angle over there. And will it always work like that? Let's think quickly. How did I get this 80 degrees? I said 180 minus 100. So the angle on a straight line, right? Then I did the same calculation. I said 180 minus 80 to get that angle, right? This is the second, number 3 under what we're going to write here. This angle at the outside here is actually an exterior angle of the cyclic quad, right? It's a side of the cyclic quad that has been lengthened, and that angle is on the outside. So this angle DCE is an exterior angle of the cyclic quad, and that is another theorem that we don't have to prove, but we need to be able to use it. That says that the exterior angle of a cyclic quad is equal to the opposite interior angle. All right, so not the one next to it, basically the one that is opposite the one next to it, if that makes sense. Right? I'm going to say that again. We're going to write it down as well, then we're done. The exterior angle of a cyclic quad is equal to the opposite interior angle. So we actually could have done that in one step. You see, that's actually the reason that I wrote down here. Z is equal to 100 degrees. Yes, because of opposite angles, if we have that 80 degrees, but even if we didn't have that 80 degree angle there, we could have said straight away the exterior angle is equal to the opposite interior angle. Okay, let's just write that one down. Oh, the right, then we can swap that around as well into the converse. If you have just a quad that's not necessarily drawn, like with the circle going through the points, if the exterior angle is equal to the opposite interior angle, then it is a cyclic quad. We're going to practice these converses separately, so don't worry about it for now. I just want us to have it written down. Okay, that is your homework as well. Cyclic quads worksheet numbers 1 to 8 with reasons, please. The cyclic quads worksheet is in this note. So I'm just going to write here, it is in document 7 on the drive. Right, it looks like this. So you're just going to have to scroll in that document until you find this worksheet. Okay, it's quite easy to see that it's the cyclic quad one. You're doing 1 to 8. Guys, I'm going to mark this homework with tomorrow's group tomorrow. So try and do it for tomorrow, or at least before you watch tomorrow's lesson. Okay, because then we're going to practice the converses. We might also do the proof tomorrow. So it's very important that you watch that lesson. Okay.